In this video, we are going to learn how to find slope. Slope, by definition, is the vertical change over the horizontal change. We also refer to this as rise over run. Other common notations would be delta y over delta x, which when broken down is y2 minus y1 divided by x2 minus x1. Now this is all contingent on the fact that the delta x, a change in x, cannot be equal to 0. Now, what is the slope of the line that passes through the given points? Now, we're going to use the slope formula, delta y over delta x, also known as y2 minus y1 over x2 minus x1. And we're going to find the slope between the points negative 3, 7 and negative 2, 4. Now, using our formula, y2 would refer to this point, the second y coordinates, while the 7 was referred to as the first y coordinate, y1. So we'll write 4 minus 7. And then x2 minus x1, same logic. This is the second point. So x2 would be negative 2 minus x1, which would be negative 3. Once that is plugged in, we can simplify our fraction. So 4 minus 7 is negative 3, but negative 2 minus negative 3 is actually negative 2 plus 3, giving us a positive 1 in our denominator. Now I have negative 3 divided by 1, which is negative 3. So the slope of this line that goes through these 2 points is negative 3. M is often used to refer to slope. In the next example, we have 3, 1 and negative 4, 1. Now, y2 would be 1 in this case, and y1 would also be 1. x2 would be negative 4, and x1 would be 3. As I simplify, I'll see that 1 minus 1 is 0. Negative 4 minus 3 is negative 7, which when simplified, 0 divided by negative 7 is 0. So the slope of that line is 0. That's very interesting that there's no change in the y. We can actually see that just by looking at the points 1 to 1, no change. Now, if you look at how much we changed from 3 to negative 4, that goes down by 7, which is reflected by the negative 7. So that way I observe the change is another way you can find slope instead of using the y2 minus y1 divided by x2 minus x1 formula. So when I see 7, negative 3, and 7, 1, I'll see that my y change is negative 3 to 1, which goes up by 4. So I can just put a positive 4. And I'll see here my x change as I go from 7 to 7 does not change at all. So I can put a 0 in the denominator, which brings us to our first problem, is that we know that this delta x cannot equal 0. If this is the case, then our slope is what we call undefined. And actually, I've learned that before, is that we can't divide by 0 in the first place. So we'll refer to this as undefined. So the answer would be the slope is undefined. Now, what do these slopes mean visually? If you go to the right side of this page, I have drawn a few pictures for us, or I will be drawing a few pictures for us. Now, a positive slope is a line that rises from left to right. So a nice example of that is I start low and I go high. That is a positive slope. Now we look over here, we have a negative 3 slope, 0 and undefined, so none of these examples would look like this first example. But a nice equation that could refer to a positive slope would be y equals 2x plus 3. We'll learn in the next video that this 2 represents the slope of that line. A negative slope is a line that falls from left to right. So you'll start up high, and you'll go down to the right. to represent a negative slope. So using that negative slope, this line could be y equals negative 3x plus 2 as an example. Now, when you have a zero slope at all, meaning you have no slope, that is represented by a horizontal line, which means that 0 times x, we get rid of that x entirely, leaving you with an example like y equals 2 for a horizontal line. Now, when we have an undefined slope, this means that the slope is so steep that it's actually a vertical line. This one's harder to represent just looking at the previous examples, but a nice example of this would be x equals negative 2. So if you imagine that this spot right here is where negative 2 is on the grid for x, we're always on x equals negative 2.